Okay, so AC power, yes, there is some instantaneous AC power formula. As we know that the instantaneous power is generally related to the power at any instant of time. So it is the ratio of two factors, that is my V and the current, that is my voltage and the current with respect to time. Now, assuming that my sinusoidal voltage, so sinusoidal voltage will be my written as Vt, and Vt will be equals to Vm cos omega t plus theta v. So this is my basically sinusoidal voltage with a phase, basically phase is delta v, or normally it is known as theta v. Now for instantaneous or sinusoidal current with a phase theta I, so it will be It equals to Im cos omega t plus theta I. So this is the value of my sinusoidal voltage, and this is the first equation, and this is the second equation. Now, as we deal with the instantaneous power, so we know that the power at any instant equals to the value of voltage with the value of time. So this will be equals to Vt value will be this one, as in elaborated in the equation number 1, and the value of It will be this one. So my Pt equals to this will be the final equation will be half Vm Im cos theta v minus theta I plus half Vm into Im, then a cos. Basically three factors are there. First is my omega, so 2 omega t, plus second factor is my instantaneous phase theta v, so it will be theta v, then the second factor my theta I. So this is the complete formula of my instantaneous power. Now there are two factors, or there are basically two parameters involved in my formula. So first parameter is half Vm Im cos theta v minus theta I. So this is basically a constant part. Now the second part, which is half Vm Im cos 2 omega t plus theta I, which is the part which is a function of time. So this is basically the function of time regards with my omega value. So this omega value says that it changes with respect to time. So this function is 2 omega t. So for this parameter, this is known as my function of time, and this will vary my parameter from one point to another. So for this instantaneous power, the parameter which is constant is my current value. Okay. Sorry, the parameter which is constant is my voltage value, and the parameter which is varying with respect to time is my current with a phase theta I. So this is the complete elaboration of instantaneous AC power. Moving towards the next. Okay, so this is the peak diagram. Peak diagram will show my instant with t upon 2 and t. This will not start with 0. There is a lag, so this lag will make a difference of what this will be cos theta v minus theta I. So this difference equals to cos theta v minus theta I. So this is basically a lag in my instantaneous power. This is the amplitude. So the amplitude will be, as I elaborated first, that the first value of my equation, that is half Vm Im, is always A, that is my amplitude, and the cos with a theta angle is the phase shift. So it will be half Vm Im, the value of amplitude. Now the second is the value which is basically the mean value to the reference value. So this is known as my average power. So average power will be equals to this value. The first parameter is known as my average value. I will write here, it will be equals to half Vm Im cos theta v minus theta I. So this is the value of average power. Average power. Okay, so this is all about my graph, which represents the value of instantaneous power. So let's move towards some numerical portion of my instantaneous power. Yes, this one. Calculate the instantaneous power and average power absorbed by a passive linear method. As there are two systems, first is Vt equals to 80 cos of 10t plus 20, and the second value, my current value, equals to 15 sine 10t plus 60. So first you have to write that for solution, it will be as Pt instantaneous power will be equals to Vt multiplied by It. Okay, so as we calculated the value of Pt, so this value of Pt will be equals to half Vm Im cos theta v minus theta I plus half Vm Im cos 2 omega t plus theta v plus theta I. Okay. Now for this value will be, first value will be equals to, I will elaborate it. The first value, that is my half Vm Im cos theta v minus theta I will be equals to 385.7. Now the second value will be equals to half Vm Im cos 2 omega t plus theta v plus theta I. So this value will be equals to 600 cos 20t minus 10 degree. So now putting these value in my this equation, this is my fundamental equation, this equation. So the value of first part equals to, so my Pt value equals to, the first part value will be half Vm Im cos theta v, so the value is 385.7 plus 600 cos of 20t minus 10 degree. So after the calculation, as this value is known as my average value, so the first part, so my P average will be, power average will be equals to 385.7 watt. So as again, I'm summarizing this. So basically the instantaneous power depends on two parameters. First, the value of voltage and current. So for a passive linear system, the value is half Vm Im cos theta v minus theta I, and for It, it will be equals to half Vm Im cos 2 omega t plus theta v plus theta I. Now these two parameters are given to us. So first value will be 385 and second value will be 600 cos 20t minus 10. So after putting the value, so first value, the value of the first parameter is known as my average value. So this is the, just a minute, this value basically is my instantaneous value, this value, and this value, the answer of this equation equals to 385.7. So this is my average value. Is that clear, class?
Yes, sir.
Okay, okay. Moving towards the next one. So next we have to find the value of root mean square, that is RMS value. So the root mean square basically is a value of quantity of mean value of squared values, which is taken for a given interval. Let us say that if the interval is between 0 to t, so there must be a root mean square value with upper limit t and lower limit equals to 0. So the root mean square value of sinusoidal curve is equal to the maximum value divided by square root of 2. So my IRMS value equals to 1 over t under root whole in the root with the integral with the upper limit t and lower limit 0. Then im square cos square omega t dt, which will be equals to under root im square divided by m with the integral t and 0 half into 1 plus cos 2 omega t dt, which will be equals to im divided by under root 2. So for a power system, so power will be equals to half Vm Im cos theta v minus theta I, and this will be equals to Im will replace with Vrm, and Vm will be replaced with Vrm. So my power value equals to P equals to PR equals to I square R, and for this there are root mean square, so it will be root mean square, or in second case it equals to V square upon R. So V value will be my RMS value, so it will be as this. So my power system, the average power for resistive loading using RMS value will be PR equals to I square R, I square into R. So I square will be my root mean square value, and the second case it is equals to V square upon R. So this value equals to the V square RMS value divided by R. Okay. Moving towards the, now there is some resistive value. Resistive equals to VRMS divided by P, then I equals to V upon T, and I peak equals to under root 2 I root mean square. Okay. Okay. Now there's a complex power. So what is complex power? Let us consider a circuit. In this circuit, yes, give me 1 sec. There's a load. Load is Z, having terminal positive and negative, and there's a voltage across them, and there's a current flowing from this load. So consider a phasor. Phasor will be V equals to Vm, okay, with angle theta V, and I equals to Im, that is peak value, with the angle theta I. These are the phasor basically we consider in the instantaneous power. So for this system, the complex power. So as the complex power, the symbol of complex power is S. Okay. So complex power that is absorbed by AC load, this load. Okay. So complex power which is absorbed by the AC load is generally the product of two parameters. First is the value of voltage, and second is the complex conjugate of current. I have to write here that my complex, I have to raise it, yes. Okay. That complex power, that is my S, depends on two parameters. Okay, first parameter will be the value of voltage, which is written as B, and second parameter is my complex conjugate of current. Complex conjugate of current. conjugate of current. So it will be I with static. So the formula is basically the complex power equals to half of the voltage multiplied by complex conjugate of current. So it will be S equals to half the value of voltage and then the value of what? Complex conjugate, which is basically induced due to the load. Here it is assumed that load is Z. So basically Z is a complex number. So we are assuming a complex number. So there must be a complex conjugate of current flowing from it. So it will be I static. So S equals to this one. Okay. Now second thing is assuming the passive sign convention. So we have to write in RMS. So it will be S equals to V RMS multiplied by I RMS, and this is the value of static. I RMS static. So S equals to V RMS into I static RMS. So V RMS value will be V upon under root 2, which will be equals to V RMS with the angle theta V. And the second parameter is my IRMS. So IRMS will be I divided by under root 2, which will be equals to IRMS with the angle of theta I. So these are the two things. So we have to place this VRMS value here and IRMS value here. But there's a hysteric, so I have to take the conjugate of it. Conjugate basically is a parameter which generally inverts the sign of my complex numbers. So let us say if the number is 2 plus 3 iota, so it will change 2 minus 3 iota, or if it is 2 minus 3 iota, so it will change into 2 plus 3 iota. So this is the purpose of conjugate. Now this is the complex power. Okay. Now taking a circuit with a load parameters. So there is a V, I, and Z. Now there's 3 parameters. First is the value of V, I, and the third is the impedance. So it will be S equals to, for this circuit, we can write that S equals to V RMS into I static RMS. So S will be equals to V RMS into I RMS with the angle theta V minus theta I. So it will be equals to S equals to V RMS I RMS cos theta V minus theta I plus second part J V RMS I RMS sine theta V minus theta I. So this is the value of my complex power. Okay, so if we are taking that the magnitude of complex power is the apparent power, so the complex power is measured in volt ampere. So you have to remember that the unit to measure the complex power is volt ampere. Also there's another power that is, or we have to notice that the angle of complex power is the power factor angle. So this will be written as Z. So we have to write this parameter in Z. So Z will be equals to, I have to just a minute, I have to write Z will be equals to V upon I, which will be this one. As I define that V equals to Vm with the angle theta V divided by Im with the angle theta I. So I can write that it will be Vm divided by Im with a complete angle parameter. It will contain theta V minus theta I. Now, the load impedance, basically this is, I have to elaborate it, that it will be equals to Z equals to, in case of, this is basically M mean value, okay? So I have to write in the root mean square value. So it will be equals to V upon I, as V equals to V RMS divided by I RMS. So it will be V RMS divided by I RMS with the angle theta V minus theta I. So as we know that V RMS equals to Z I RMS and S equals to V RMS with the I static RMS. There are basically two parameters. First is by the value of VRMS, which will be equals to Z into IRMS, and then the value of S, which will be equals to VRMS into the value of I static RMS. So what to do? So this will be equals to S equals to I square RMS into value of Z, which will be equals to V square RMS divided by Z static, which will be equals to V RMS into I static RMS. So there is another parameter that what is Z. So then one Z is the value of impedance, and second Z basically, which is used here, is the complex number. So it basically consists of two main parameters. First is real part and imaginary part. So it will be written as, so my Z value will be written as R for real parameter, then plus J is my iota value or a complex value into the value of X. So S will be written as S equals to I square RMS into the value of Z, which will be equals to V square RMS divided by Z static. Or sometime it is also for your, this is basic two parameters used, but there is another formula which is commonly used for to find the value of S, which will be equals to S equals to VI. Okay, so it is V RMS, but the I value is I static RMS. So remember these. So this is the first formula to find the S. This is the second, and this will be the third one to find the value of S. So as S equals to I square RMS into real part plus J, which is the value of complex polynomial. It is generally known as iota value, plus J equals to P plus JQ. So my final value will be S equals to P plus JQ. Now I have to elaborate here. Here the P is the real part, and Q is my imaginary part. Imaginary part. So I can write that this is my real part of S, and this is my Q will be my imaginary part. So after this I have to write in my, so my as I write here that S equals to I square root mean square with the value of R plus JX, which will be equals to P plus JQ. Okay, so the P will be written as my real part of S, which is basically I square root mean square into I, and second is my Q value, which is the imaginary IM with the S, which will be equals to I square root mean square with the value of X. So P is the average, or generally it is known as real power, and it depends mainly on the load resistance. P. Second thing is Q depends on load reactance X, which is known as reactivity or reactivitance, okay, of power. So this is all about my complex power. So hope you understand it. Okay, so this is elaborating that for a complex parameter, it is equals to half V into I static. So it will be VRMS into IRMS with the angle value, which is theta V minus theta I. So there are three things in the formula. Just give me 1 second. I have to write here. Okay, as S equals to half VI static. So if I write this value in root mean square, so it will be VRMS, IRMS with the angle value. Angle value is theta V minus theta. Okay. Now the second thing is S will be equals to VRMS, IRMS cos theta V minus theta I plus J VRMS, IRMS with the sine value. Sine value is for theta V minus theta I. So the thing which must be taken control, that this value will be my P value. Okay, so J will present Sam, it will be J here, and this value is my Q. So my S value will be written as S equals to P plus J. Here P is the average power in watt delivered to a load unit, and it is the only useful power. Okay, so P is basically the real part is only firstly you have to know that the P is the average power, which is generally expressed in watts, and it is generally sorry, it is generally delivered to a load, and it is the useful power which is used to find the value of complex power in a given circuit. The Q is basically the reactive power exchange. Okay, remember that the Q is the reactive power exchange between the source and the reactive part. So it is basically the unit is VAR variable. Basically, if Q equals to 0, then now there are three things to do. So give me 1 minute. Then give me 1 minute.
Okay.
Okay, okay. So there is basically Q. So again, so Q is what? Q is reactive power exchange, reactive power exchange, and it will depend on three parameters. First, it is Q equals to 0. If Q equals to 0, what happens? If Q is greater than 0, what happens? And third is if Q is less than 0, so what will be the case? So if Q equals to 0, for resistive loads, so Q equals to 0, it is only for resistive loads. For resistive loads. So please write it down. These are the main points for the complex power. So Q equals to 0. It is for resistive loads and unity PF. When Q is greater than 0, it is for capacitive loads. It is for capacitive loads. And it is leading PF. Q is greater than 0, so it will be the inductive loads, which is basically lagging PF, meaning the power, complex power. So this is all about the complex power. These are basically the average power and reactive power. So average power is P and reactive power is Q. So due to sinusoidal voltage, so it will be P equals to Vm Im divided by 2 into cos of phi, which will be equals to V RMS into IRMS cos phi. And Q will be, so P is the real part, which will be equals to cos. You have to remember it. And Q is the imaginary part, which will be, or it is known as reactive power, and it depends on sine of angle. Okay, a sinusoidal voltage basically source. No, first thing to note here that a sinusoidal voltage source of RMS, which is known as VRMS, and DC voltage source, okay, of constant voltage delivers the same average power to the load, which is basically delivered by resistance. So it will be right here that VRMS, which is the value of RMS, and VS. VS is what? VS is the source of constant voltage. So this value, VRMS value, is always equals to VS. Okay. So the next is power triangle. So power triangle is, just give me 1 second. Power triangle is a triangle which is used to find the magnitude and the direction. So let us say that assume this theta. Assume theta I will be equals to theta. Then the time varying part will be equals to P TV equals to P cos 2 omega t plus Q cos 2 omega t plus 90 degree. Again, power of triangle, okay, will be equals to P cos 2 omega t plus Q cos 2 omega t with the angle which is 90 degree. So it will be written as P TV with respect to time equals to P cos 2 omega t plus Q cos 2 omega t plus 90. So okay. The phasor, now moving towards the phasor for the first term. The phasor for the first term is basically here, which will be P is less than 0 degree, and for Q is basically less than 90 degree. So these are the two phasors which are used. The reactive power Q is ahead 90 degree to the phasor. Which is known that the reactive power Q is in leading the power P with 90 degree angle. Okay, so we can write that P having angle 0 degree and Q with the angle 90 degree. So we can write that S equals to, as we know that P plus JQ. So the value of S equals to, for magnitude, it will be equals to P square plus Q square. And the theta value will be equals to tan inverse Q upon P. Okay, so P must be equals to absolute value of S. S is basically my power, instantaneous power with the vector diagram. So it will be equals to cos theta and Q equals to S sine theta. So theta will be equals to, again, it will be equals to tan inverse Q upon P. That it will be equals to tan inverse S upon this parameter and this parameter. So this will deliver us the value of theta for the whole power triangle. Now the next is the power factor. So power factor is the relationship between the current and the voltage. Okay, so this is the power factor. Now power factor will be depends on real part and imaginary part. Let's move towards the numerical section. Yes, this is the part. Yes. Now this is the problem 11.3. Find the average power absorbed by resistor and inductor, and then find the average power supplied by the source. Okay, so how to do it? So first thing to do is, as this is the voltage source, the given things are 8 with the angle of 45 degree. Then there's a resistor value is 3 ohm. Then there's an inductor L value which will be equals to J 1 ohm. So my I value will be equals to, as I equals to V upon Z. So how to find the value of Z? So Z for this circuit will be equals to this one. So it will be, Z will be equals to 3 plus 1J. So I write the value of I equals to V upon Z, where V equals to this one, 8 angle 45 degree with divided by 3 plus J. So we can find, so this will be 2.53 divided by 26.57 degrees. So this is the value of I for the system. So we have to find the value for the resistor. So for the resistor, it will be equals to IR, which will be equals to 2.53 with the angle 26.57. So the voltage across the resistor equals to 3 times, this is the value 3I. So 3I will be 3 multiplied with the value of I. The I value is 2.53 with the angle 26.57 degree. So this will multiply with this one. So my I value will be 3 multiplied 2.53. This will be 7.59 with the angle of 26.57 degree. So this is we find the value of IR and then VR. Now I have to find the power value for resistor. So it will be equals to PR, which will half PM IN. So it will be half VM value will be equals to Okay, now VM value equals to this one, VM and IM value. So yes, so this will be equals to 2.53, 2.53 with the value of IM value 7.59, 7.59. So after the calculation, it will be equals to 9.6 watt. So this is the method to find the value for resistor. The current for resistor, voltage for resistor, and then the power for the resistor. The next is to find the values of current, voltage, and power for inductor. So this will be equals to IL. IL will be equals to 2.53 with the angle 26.57 degree, and VL will be equals to JIL, which will be equals to 2.53 with the angle 26.57 plus 90 degree. So this will be VL equals to 2.53 with the angle 116.57 degree. For it is a polar, so it will divide with the angle. So PL will be equals to half 2.53 square with the cos of angle. So cos of angle is cos 90 degree. As the cos 90 equals to 0, so PL equals to 0. So this is the value. Now we have to find the average power supplied. So the average power supplied will be equals to P half the value of 8, this one, then the 2.53 the amplitude, and then the next it is cos of 245 degree. This is the angle, and second is 26. This is the value of current, so it will be 26.57 degree. So my P value will be equal to 9.6 watt. So this is the complete solution of this numerical. Now for this, with the practice problem 11.4. So how to do it? For this system, first we have to do is we have to find the meshes. Okay, so there will be a mesh 1. This is the mesh number 1, and this is the mesh number 2. So it will be equals to, for mesh number 1, the value will be equals to -40 plus this one 8. This is the impedance value, so 8 minus J2 with the current value I1 plus we have to neglect this value with respect to I2, so it will be minus J2 with the I2 value equals to 0. So this is the first thing. So it will be equals to -40. Sorry, minus. I have to elaborate it. I have to, after simplification, this will be equals to 4 minus J I1 minus J I2 equals to what? Equals to 20. So this is my equation number 1 for this system. For what? For this system, this mesh number 1. Now I have to find the values for mesh number 2, this one. So this will be for mesh 2, for mesh 2, it will be will be minus J20, this one, this value. So minus J20. Then I have to sum it with plus J4 minus J2 with the I2 value plus minus J2 into the value equals to I1 equals to 0. So it will be negative I1 plus J I2 equals to J10. Okay, so it will be equals to what? Again, I will elaborate it. This will be equals to J equals to minus J. This one, this is the first equation in second. I have to make a matrix. So for first, it will be equals to 4 minus J. 4 minus J. And the next will be 4 minus J with the negative this sign. So this will be my what minus J. Now this one, it will be minus J and plus J, minus J plus J with the value I1, I2, which will be equals to 20, this value, and the second is J10. So these are this is the matrix form. So after matrix, we have to find the values to complete the equation. So it will be equals to I1 equals to delta 1 upon delta. So the value will be this one, and again for I2 it will be equals to delta 2 divided by delta, and the value equals to this one. So this is the values which will be given. So as the power P of S equals to negative 1 upon 2 with the voltage value which will be equals to 40 with the current value 5 into cos minus 50, this will be minus 60 volt. For the second, it will be same minus 2 with this value 20 with the value of 13.6 with the cos 90 minus 17.11. So this is the value of that P equals to half 40 into 5. So it will be equals to 100 watt. It's the method to find how we find the value of this, the average power absorbed by the inductor and capacitor. Okay, moving towards 11.1. So let Vt equals to this one and It equals to this parameter. Find the phase shift. Okay, so as we know that the P equals to Vm divided by 2 with Pf. So the value of Vm is 100. This is given here, and the for Im this is given here with the divided by 2 with the Pf power factor equals to 0.5, which will be equal to this one. So and the Q equals to Vm Im sin theta. So the value will be, this is the formula. So Q equals to Vm Im divided by 2 with the sine of theta. The complex power will be equals to S equals to what? S equals to P plus JQ. So you have to put P value here and Q value here. So it will be equal to this one. The apparent power will be equals to the real value, that is the 400. Again, we have to find the value of theta minus theta V, theta V minus theta I. So it will be 120 degree minus 60 degree. Where is the 60 degree is indicated here? So this will be equals to 60 degree, and the value of power factor will be cos of theta, which will be equals to cos of 60 degree, which will be equals to 0.5. Okay, let's move 11.2. Find the average value for the average power 1.63 with the power factor this one. So S will be equals to P upon F. So this is the value, and Q will be equals to, the formula is S F into 1 minus PF square. So the value of S is 1890.9513 with the under root 1 minus power factor equals to 0.862 whole square. Okay, so this is the value of Q. So S equals to P plus J. So it will be P equals to 1630 plus J. J will be 485.8913 BA. This is how we find the value of this system 11.1. Okay, 11.3 is totally same. So just you have to find with P equals to V S into VF. So what is the value load? That is 23.7 and the value 0.8876. So this is the required answer. Then Q equals to S into under root 1 plus 1 minus P square. So S is given here and power factor is here. And from this we have to calculate P, find here, put here the value of P and Q here to find the value of S. So this is the easy numericals. Moving to 11.16, which is basically find the complex power, average power for the system. So how to find? So first the inductor, the ZR given as 120. So VL will be J omega L. J with the omega value is 2 pi, and 50 with the value of L is 0.2. So this is the value, and CC will be 1 upon J omega C. So this is the value of C. So VR will be equals to 150. VL will be equals to J 62.8319, and GC will be negative J 159.1549. So this is the ZR value, ZL value, and GC value. So my total impedance value equals to ZC, which will be parallel to ZR plus ZL. So Z value equals to ZC multiplied by ZR plus ZL divided by ZC plus ZR plus ZL. So this is how we find the value of Z for the system. So the value of Z will be this one. Give me 1 second. Now for the value of S value basically equals to VRMS square with Z value then whole divided by Z square. So this is the 220 square VRMS value. With the Z value is this one I find divided by the Z square. So this is the value of S for my system. Okay, so R will be the real part, Q will be the imaginary part, and for power factor it will be equals to S upon S. So it will be equals to 0.9163. Now the next example is the voltage across a load is this one, and we have to find the complex and apparent power, real and reactive power in this one. So as we know that VRMS value equals to what? V value Vm divided by under root 2 with the phase angle theta V. Okay, so what is the value of Vm? Vm value is 60 here, so it will be 60 divided by under root 2. What is the value of theta? Theta is minus 10, so it will be angle of minus 10 degree. For IRMS, which is same, so it will be IM, which is 1.5 divided by under root 2 with the angle 50 degree. So S equals to the product of these two, 60 divided by, this is the value, first value, and this is this value, and this is second value. So my S value will be equal to this one. So the apparent power will be 45. So 45 will be my apparent power. This is the complex and apparent power. So this is the complex power complete, and this is the apparent power. And we have to find the real and reactive power. So real power will be S equals to 45 with angle. So this will be equals to 25 and this. So S equals to P plus JQ. So P real part is 22.5, and the apparent power is reactive power is minus 38.97 PR. So now this power factor, so power factor will be equals to PF will be equals to cos of theta, which will be equals to minus 90 degree, and the load impedance will be equals to B upon I. So it will be equals to 60, the magnitude with the angle negative 10 divided by 1.5 with the angle plus 50. So this is the value of impedance for my system. Now we have to find the average and reactive power as SAM. So for this, P equals to P cos theta. So this is the value, and second Q is equals to Q sin theta. Now finding the peak value. So IRMS static will be S over this one. So putting the value in this one. So IRMS equals to 100 divided 100 into angle 31. So IM, which is the peak value, equals to under root 2 upon RMS. So IMS to under root 2 into IMS value, that is under root 2 with the value 100. So it will be equals to 141.4 ampere. Achha, now this C part is the load impedance, so it will be C equals to VRMS divided by IRMS. So it will be 120 with the angle 0 degree divided by 100 with the angle negative 31.13 degree. So this is how we find the values of the average and reactive peak power, the peak current, and the load impedance. Now moving towards the next one, 11.2. So this is the simple one to find the value of S will be equals to P upon PF, Q equals to this one, and S equals to P plus JQ. This is the simplest part we have done before. This is as same as. This is one point we have to find with respect to S. So S will be equals to, as I described, S equals to under V RMS square with the value of impedance Z with the whole value of the Z square. So it will contain two parts, real part. So P real part will be real part of S equals to 0, and Q, the imaginary part of S, will be equals to V RMS whole square divided by omega L. So these are the two things to find the value of P and P value and Q value. Okay. So this is same as before. Now 11.66. So for 11.6, just we have to find GL, GC. Then finding that these are parallel to each other, and then again the same formula with the real part and imaginary part, and the power factor will be equals to real part of S divided by S magnitude. So the value equals to 0.9163. So this is also the same as we done before. So just summarizing that, first we have to find the value of S. this will be equal to P upon PF. Then Q value, then S equals to P plus JQ. Now the next is Z. So Z will be equals to Z will be equals to and VRMS square divided by S static. This will be equals to 38.1472 and X will be equals to imaginary part of Z and R will be equals to real part of Z. So the real part, the value is 38.14 and the imaginary part equals to 16.93. Here the value of L, which is the value of inductance or impedance, will be equals to X upon W. So this will be equals to this will be equals to 44.9141 milli Henry. Okay, so yes, you have to delete it. These questions are same, basically just repetition. This is also the same as this one, conservation of AC power. So for AC power, find the complex power of all the elements with the power V factor VST equals to 300 cos 2 pi 60t with the value V. Now this is the value of ampere, so the amplitude, and this is the value. There is no phase, so the angle will be 0. First we have to find the value of ZR1 will be 90 degree. For ZL1 it will be equal to J this one, and ZL2 will be this one. For ZC, the formula will be 1 upon J2 pi omega. Now we have to find the value of impedance equivalent. So it will be equal to Z equivalent, which will be equal to ZR1 plus ZC, which will be parallel to ZR2 plus ZL2. So it will be equal to ZR1 plus ZC multiplied by ZRC plus ZL2 divided by ZR1 plus ZC plus ZRC plus ZL2 this one. Yes, one. So this is the value of Z equivalent. So the value of Z equals to, for whole circuit, will be equals to ZR1 plus ZL1 plus Z equivalent. So for this, I have to find that the I equals to Vs divided by Z. So the Vs value is this one, and Z value I find from this. So this will be written here. So I have to find that V2 equals to I multiplied by Z equivalent. So it will be equals to this value. So I1 will be equals to this one, and I2 will be this one for this system. Okay, so the voltage parameters, I have to write here again that VR1 equals to ZR1 multiplied by I. VL1 equals to ZL1 multiplied by I, and it will, for ZR2, this is ZR2, it depends on I1. For ZR3, it depends on I3. So these are basically depend on I2. These are dependent on I1. And this is dependent on the value of current, that is I. So just putting the values of Z and I can find the values of VR1, VL1, VR2, VC, VR3, and VL2 respectively. Now for S values, so S will be equals to same for all parameters. So S will be equals to SV equals to SV source will be equals to half Vs multiplied by negative of I with a complex conjugate. So the value will be this one. VR1, the value will be same. So we can use the same formula. So this is the method to find the value of VSPS, SR1, SL1, SR2, SC, SR3, and SL2. So this is by summing all the values. So the formula is same. Just we have to put the values of VR1, VL1, and we can find the values of S respectively, and these all values we have to sum it. So sum all the complex power will be equals to 0. So we can find the values that this will be equals to 0. Yes, the sum of all the complex power equals to 0. So the real part of the complex power is this one, which will be equals to minus 220 is the average power. Okay, so the average power that PRS plus PRS2 plus PR3, which will be equals to 220, and the imaginary part, which will be my QL1, QL2, and QC, is 59.643. So there's a real part and there's an imaginary part. Okay, imaginary part. So real part is my PR1 plus PR2 plus PR3, and the imaginary part will be QL1 plus QL2 plus QC. So this is the way to find the values of my. So this is basically the problem related to my conservation of complex power. Again, this is the compiling the solution of 11.9 again. So okay, so this is the electricity consumption cost. So how to find the electricity consumption cost? So a manufacturing industry consumes 200 megawatt hour in 1 month. If the maximum demand is 1600 kilowatts, calculate the electricity bill based on following two rates. So there's a remember that there are two charges. First is my demand charge, and second is the energy charge. So demand charge is $5 per month, and the energy charge is 8 cents per kilowatt hour for the first 50,000 kilowatt hours. So the 5%, 5 cents per kilowatt for the remaining energy will be. So first you have to find the demand charge. The demand charge will be $5 multiplied by 1600, which will be equals to dollar of 8,000. So this is the demand charge. Demand charge. Now the energy charge. So the energy charge for 50,000, so it will be 0.0. This is basically 8 cents. Okay, so 8 cents will be $0.08 multiplied by 50,000, which will be equals to $4,000. Okay, so the remaining energy is, now the total energy for this system is 20 mega kilowatt watt hour. So it will be 2 lakh, then minus 50,000. $2 lakh minus 50,000, so it will be equals to 1 lakh 50,000. 2 lakh minus 50,000 equals to 15,000. So the energy consumption for this will be equals to as it is equals to 5 cent per kg remaining, so it will be equals to 0.05 multiplied by 1,50,000 equals to 7,500. 7,500. So the total bill for the month is 8,000. This one, the demand charge plus the value of this one. This is my 4,000 plus 7,500, which will be equals to 19,500. 19,500. So the total bill for the month will be equals to 8,000, which is the demand charge, the energy charge, and the and next will be my 7,500. So this is the basically these are the three major parameters to follow. So I have to consider both three parameters. So it may appear that the cost of electricity is too high, but this is often a small fraction of overall cost of production. So it will be selling price of the finished product. So this is the thing related to my electricity billing. So it will be equals to one major thing. So it will be equals to three parameters. First is my demand charge. Just give me 1 minute. Okay, so it will be demand charge, energy charge, and the percentage remaining, which will be equal to 0.05 cents. So this will be equal. Now example number 2 will be the energy cost. So this will be equals to W equals to 300 multiplied by 520. Then the delta charge will be 5 into this one. So WT will be W multiplied by this one. So total energy required, that is W plus delta W. So it will be 780 plus 1,56,780. Sorry, it is 1,56,000. So it is 1,56,780 kilowatt hour. So the cost for this one is, so as we know that for this system, so for this system, cost will be equals to 6 cents multiplied by WT. So 6 cents will be 0.06 multiplied with the energy consumed. So it will be 1,56,780. So this will be equals to 9,406.80. So the cost will be this one. So this is the end of this numerical. No, this is the summary for the complete part for number 1. So the instantaneous power will be equals to P plus P cos 2 omega t plus 2 theta minus Q sine 2 omega t plus 2 theta I. Now the average value is equals to 0.5 Vm Im cos theta. The apparent power will be defined as S equals to VRMS into RMS with the value of VA. So the power factor will be equals to cos theta V minus theta I. So it will be equals to, general it is cos theta. So Q value will be equals to this one. Now S equals to 0.5 VI, static equals to S, and for VRMS, for RMS value, it will be equals to VRMS RMS. So just give me 1 minute. So this is how we find the values of following parameters. So the next one is the complex power. We use all these formula to find the values and the equivalent impedance. So equivalent impedance will be equal to this one. So these are all the formulas which are basically used in this system. So yes, these are the formulas. So hopefully you understand each and every point. So Zen, is there any question from this part? Zen, hello. 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 Okay, give me 1 minute to change the next part. So my next part will be here, not here. It will be the part number 2. There is also, yes. So we have to start the part number 2. Yes. So for part number 2, AC power, part number 2, chapter number. So this is the same. So for this, now find the complex power of all the elements. So how to find the complex power of all the elements for the circuit? So for complex power, it is VRI, VR1, VR1, VR2, VC, VR3, and VR2. So we can use by using this same formula. So it will be ZR1 multiplied by ZL1 multiplied by ZR2, VC, ZR3, and ZL2 respectively. So okay, class, give me 2 minutes break. I will join you after 2 minutes. So as the value of VR1, the VL1, VR2, and then VC, VR3, and VR2 are respectively. And we can find by the following: VR1 will be equals to ZR1 with the value of current. So it will be 132.2044 minus J 35.7893. So VR1 will be equals to 136.963. Just give me 1 second, class. So this is the value of VR1. Sorry for interruption, class. So 136.963 with the angle of what? It is given here. So we can find using phasor formula, that is delta P. So delta V will be equals to theta V divided by theta I. So this will be equals to minus 15.1476 degree. So as from this formula, we can find VL1 VL from this equation. So as we know that the source current for this R1 and L1 is I. Now moving towards the next part, which is this one R2 and C. The source current is I1. Now for R3 and L2, it is I2. So these parameters are changing with respect to I. This is basically I1, and this will be the I2. So for this, I can write here, this is the value of the first one. So my second value then will be VR2. So VR2 will be ZR2 with the value of current, that is I1. So it will be equals to the first value is by 91.9522 plus J value is 50.2872. Now I put the value in A cos 2 omega t plus 5, and my value will for VR2 will be 104.8047 with the angle deviation equals to 28.6735 degree. So this is the value of VR2, and simultaneously we can solve VC for this equation. Now moving towards the third part, which is generally this part, which is related to I2. So it is VR3, which will be equal to ZR3 with the value of current. Now current source is I2, so it will be I2. So it will be 60.4 4356 minus J 99.0583. So again, by using Phasor formula, we can transform this equation into 116.0389 with the angle of minus 58.6126 degree. So this is the value of VR3. So now I will write all the values. My VR1 value will be equals to 136.963 with the angle minus 15.14 degree. VL1 value will be 22.4871 with the angle 74.85 degree. VR2 will be 104.8047 with the angle 28.67 degree. VC will be equals to 111.2012 with the angle 61.32 degree. Now VR3 will be equals to 116.0389 with the angle 58.61 degree. And the last one is VL2, which will be equals to 99.4219 with the angle 31.3874 degree. These are all the 6 values to find. We find all the values in this equation, example 11.9. So these are the basically ZL1 value, Z equivalent value, then I value, and from this we can find all the values of SV. So SV will be, sorry, SC will be equals to, or the total S for the system will be equals to, just give me 1 second, yes. Total S will be equals to SVS, yes, plus SL1 plus SR2 plus SR3 plus SC, and plus there is the last part is L2, so SL2. So I have to sum all the values. So SVC value equals to this one, that is 104.2159. SL1 value will be this one, which will be equals to 61.2046. SR2 value will be equals to SR2 value will be equals to 97.3214. SR3 will be simultaneously equals to SR2. Then SC1, yes. So these are the values, that Z equivalent, ZL1, ZL2, ZC. So we have to put all these values to find the value of, to elaborate all the values. So imagine, or there are two parameters. First is the real part, and second is imaginary. So always compute with respect to my basically 2 parameters. First will be my real. So you have to take all the real values on left hand side, and the conjugate values or the complex value to the left hand side, right hand side. Okay. Now the next is maximum power transfer. So maximum power transfer, just go to the example. So for the circuit below, this is 11.16. Find the load impedance Z load. So where is the Z load? Z load is this one. This is the Z load of this system. Okay. So we have to find the maximum power absorbed by the load. So as we know that, first you have to find the what? Maximum power. So class, always remember that For a given problem, first you have to write the formula how to find. So this value will be, or this typical question will be solved by using Thevenin theorem. So it will be equals to V Thevenin square divided by 8 R Thevenin. Again, the maximum power absorbed by the load using the Thevenin theorem is given by P max, which will be equals to V Thevenin square divided by R 8 R Thevenin. So now how to find V Thevenin and R Thevenin respectively. So for V Thevenin, it will be equals to Vs. So what is the Vs? It is basically 150. So it will be 150 plus 0 J0 degree V. This is the value of V Thevenin. Now moving towards R Thevenin. So how to find R Thevenin? R Thevenin value is this one. So for R Thevenin value, it will be Z Thevenin equals to ZR1 plus ZR2. This is the value of ZR2 plus ZL multiplied by ZC all divided by ZR2 plus ZL plus ZC. So from this we have to find this parameter. So my P max will be equals to, now before computing the formula, you have to do a simple calculation. So my two parameters V Thevenin will be equals to this one, that it will be equal to 150 plus J 0 and the 0 degree V, and the R Thevenin value will be equals to 230.6731. Now we have to find this. We have to put all these in the formula. So P max will be equals to V Thevenin divided by 8 R Thevenin. So P max will be equals to 150 square divided by 8 multiplied by R Thevenin is 230.6731. So after the calculation, my P max for the system is 12.1926. Again, summarizing this basically, this is the important numerical. We can solve using Thevenin theorem. So we have to find the power maximum. So the formula of power maximum equals to the ratio of V Thevenin squared divided by 8 R Thevenin. So we can find the value of V Thevenin, which will be equals to basically V source and R Thevenin by using the formula. So this is the required answer for this numerical. Okay. Now moving towards 11.12. The circuit basically shown in the figure 11.25. We have to find the inductance value L to increase the power factor to 0.9. So any question from class till now? Zen? Yes, any question? Okay, is it clear?
Yes, sir.
Okay, okay, Zen. So for this, we have to find first V source. So V source is again the value of amplitude, that is the 220. With the angle, there is no shift, so there is 0 degree. With the VC value, as I know that it is equals to 1 upon J omega C. So this value equals to this one. So Z value is this, V load, and then I equals to Vs divided by Z. So it will be equals to 1.023 plus J 0.8683. So V load equals to 189.3114 minus J 26.04. Simultaneously, I can find the value of S load, P load, Q load. Now, to find the power factor, PF1, it will be equals to P load. It will be equals to 1 upon J 0.8683 plus J 26.04. Simultaneously, I can find the value of S load, P load, Q load. Now, to find the power factor, P1, it will be equals to P load. It will be equals to 1 upon J 0.8683 divided by S load. So this value will be equals to 0.6671. Yes, yes. After dividing, yes, this is the value. Now PFF, this value equals to 0.99. So I have to find the QF. So QF formula is minus P load multiplied by whole under root 1 divided by PFF square minus 1. So you have to put the value of P load. P load value is 171.038. Then PFF value equals to 0.99. So after that, putting the value in the formula of QF, so QF value equals to minus 24.371 VAR. Then after we have to find the value of QL. So QL basically depends on two parameters as I described earlier. So it will depend on two things, QF and Q load. As the direction of load is reverse, so Q load will be equal to QF minus Q load. So QL will be equals to, again, QL will be equals to QF minus, QL equals to QF minus Q load. So what is the value of QF? QF value is minus 24.3716 minus the value of Q load. So Q load is minus 191.0284. That will be minus 24.3716 plus 191.0284. So this will be equal to 166.6568 VAR. So my load value will be equals to V load square divided by Q load W. So this will be equals to 581.2262 millihenry. Okay. Again, for this problem, the average power on the load is 2.75, and the given is V root mean square value, which will be equals to 320. So first we have to find the value of S, that the complex number S, which will be equal to P upon power factor. So P is the load and PF is basically power factor. So the ratio of both will be equals to 3604.194. Then you have to find the two parameters of S, that is the real part and the imaginary part. Real part is Q and the imaginary part is the my R. So you have to find using formula. So S equals to P plus JQI. So this will be equal to 2750 plus J value is this one, 2329.7415. Now we have to find the value of QF. So QF, as I have done before, that P into whole under root 1 upon PFF whole square minus 1. So we can find the values. We can put the values in this formula to find the value of QF. Now QC equals to QF minus QI. So just you have to find the value of QF here and QI here to find the value of QC. So now there is the third parameter, which is the extra parameter added in this numerical. So see that the capacitance value. So capacitance value equals to minus QC divided by V root mean square value, the square of this with the omega. So what is the value of QC? QC value is negative 2053.7093 divided by V root mean So V root mean will be 320 square with the value of W. So W value will be what is the omega value? Omega value is given here. So you can put the value omega here. So C value equals to 53.1995 microfarad. So you can use also MATLAB to find these parameters. So you need to put the values of SPQ value, and then putting the value of power value and PF value to find this in the MATLAB. Okay, this is same as before. Example 11.14. This is also the same, just using the same formula to find the values. Okay, so here it comes the summary that the instantaneous power and the other powers that are related to each other. So the instantaneous power. Now this is the summary of the equation of the complete chapter. The first thing is instantaneous power, PT, which will be equals to power P plus two parameters. First parameter is my real parameter and second is my imaginary parameter. So P plus P cos 2 omega t plus 2 theta I minus Q sine 2 omega t plus 2 theta I. So this is the formula to find the value of instantaneous power for a system. Now the average value of the instantaneous power will be given as P equals to 0.5 Vm Im cos of theta. So as this is given as my average value of instantaneous power is known as the average power, and this will be equals to 2 parameters of VRMS. So VRMS and IRMS. So first thing to do is P equals to 0.5 Vm Im into cos of theta, and the S equals to VRMS multiplied by IRMS VA. So VA is basically volt ampere. Now the next thing is the power factor. Okay. Now the power factor is written as PF, smaller PF, which will be basically equals to cosine angle cos theta V minus theta I, and which is taken as cos theta. So this is the value of power factor, which will be equal to cos of theta. Now next one is the value of Q, that is reactive power. For reactive powers M, it will be equals to Q 0.5 Vm Im sin theta. So it will be VRMS into IRMS sine of theta. So this will be S sine theta. So it will be plus minus the value of complex number S into 1 minus PF square. So this is the value of reactive power. Okay, so this is the what? This is the value of reactive power of our system. Now complex power will be S equals to 0.5 V into the value of current. Current basically which is denoted as I static. I static is my complex current, which will be also equals to real part P plus JQ. Okay. Now the complex power, as we know that S equals to VRMS into IRMS value. IRMS value of conjugate. So this conjugate is written as static. Now VRMS equals to, as we know that Z equals to V upon I. So V equals to ZI. So I replaced here, so it will be Z IRMS multiplied by IRMS static. You can write that S equals to Z with absolute value of IRMS square. So Z equals to R plus JX into IRMS value. So this is the parameter of S. Now the equivalent impedance will be equals to Z, and Z will be equals to S upon IRMS square, or it will be equals to VRMS square divided by S square. So this is the parameter to define the value of equivalent impedance for a system. Again, Z equals to VRMS square divided by S static into S. So this will be equals to VRMS square with the value of S divided by absolute value of S square. So the complex power released by the sources equals the complex power absorbed by the impedances. So this is known as conservation of power. Okay. So the next thing will be the complex things or complex power defined. Sorry, this is the power factor. Power factor is also the value of cos theta, and we can find by using P upon S absolute. S absolute will be P upon PFI. Okay, and sine theta will be Q upon S absolute. So the absolute value of S equals to Q absolute divided by 1 minus PF square. That's it, 1 minus PF square. So again, for P value, it will be equals to Q multiplied by power factor. So first thing to note that this power factor will be multiplied and divided both sides. So it will be added to the value of Q, and it will be added with 1 as a square. So it will be PF square in the denominator and QPF in the denominator. So after the elaboration, we can find the value of P for my system. Okay. Again, for the last thing, this is the all these are the all the formulas that are used in my chapter number 11. So any question regarding this chapter? Class, any question? Is there any question? No question? Everything is clear? If everything is clear, I want you 2 to 3 minutes for a quiz. Is everything clear? No? Okay. Okay then. For any question, you can email me if there is any difficulty regarding the numericals. So the major portion in chapter number 11 is the numericals. So first you have to practice all the formulas regarding the power impedances, power factor, power cofactors, then transformers, then impedance values, then billing system, then impedance and conjugate impedance, conjugate current, all these values and the formula of every parameter must be practiced by yourself in order to pass the exam. Okay, so chapter number 11 is the important for your midterm. So concentrate on chapter number 11. So again, any question from the whole class? Is there any question? Zen, is there any question? Okay, no question. So
No, sir.
okay. So that's it from today's lecture. In case of any questions, then you can email me or you can send the query to Dr. Usman and I will let you know. Okay, so this is all about today's lecture. So hope you enjoyed each and every moment of this lecture, and goodbye from this lecture.
Thank you, sir, so much.
Okay, thank you. We'll meet soon. Okay.